Hello, hello, hello. This is Nicholas, and I just found out yesterday that the football manager went to the bank because he wanted his quarterback. Anyways, uh, I found out a pretty cool way of multiplying two numbers together that is called Japanese multiplication, um, otherwise known as, I kind of think of it as lattice point multiplication. And I find it especially helpful for me because when I tell people, "Oh, I really love math," they say, "Okay, well, you know, what's a Google? What's a Google times like the square root of e to the nearest like thousandth? Quick, you know." And I mean, this is not what we do, right? This is this is so stupid. But Japanese multiplication really is pretty cool and pretty quick, and I think geometric way of multiplying two numbers together that you might show to somebody that may go, "Wow, that's pretty cool." But knowing why it works is also very interesting, so I wanted to make a quick video on it. So to start, let's kind of do a simple case here. Let's do 13 times 21. And I'm even going to draw the little x here instead of a dot, just because I want it to be accessible. So traditionally how we do that is we'd say 13, 21, and we'd multiply across like this. So 1 times 3 is 3, 1 times 1 is 1, we put a 0, 2 times 3 is 6, 2 times 1 is 2. Add them together, 273 is our answer. Now, the way the Japanese thought to do it is actually with lines. So what I'm going to do is, and I'm going to keep this part up here to show how it actually is very similar to the geometric way that I'm going to show you now. So first I'm going to draw one line slanted about like that for this one right here in the 13. And then a little spaced out from that, I'm going to draw, three more lines close together for the 3 in the 13. Now, kind of perpendicular to those, but at the same type of slant, I'm going to draw two more lines like so for the 2 in the 21. And then lastly, I'm going to draw one more line spaced a bit out from the 1 in the 21. And now I'm basically going to count or mark where these lines intersect. So we have an intersect here, 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 here. All right. And now I'm going to divide these intersections up into some groups here. So I'm going to divide. We have one group of Ooh, wow. I thought it would be a little better than that. We got a group of intersections there, a group of intersections here, and then a group of intersections right here. And so now it turns out that this is going to be the ones place, the tens place, and the hundreds place. And I'm going to elaborate a bit more on this later. So basically we say how many intersection points do we have right here? Well, we have 3 in the ones. We have 1, 2, 3, 4, 5, 7 in the tens, and we have 2 in the hundreds. And look at that, 273. Voila. Now, truthfully, the way that I did this Japanese multiplication is just geometrically saying the same exact thing as this. So, for example, when I did the 1 times 3 right here and I got this 3, that's exactly what shows up right here for the same exact reasons. Hence why it's in the 1 spot. And there were no more intersections when I did multiplication by this 2 right here, so there was hence a 0. And there was nothing more that I needed to add. But in the case of the tens place, right, the case of this place right here, I'm going to get a 1 from this multiplication, which is shown right there, right? Because that is the 1 from the 13 crossed with the 1 from the 21. So it literally is the 1 times 1 right here. Now, we're also, of course, going to get the 2 times 3 right there, which is just 6. And that is shown right here. So we have the 2 from the 23 crossed with the 3 from the 13. And that's going to give us 6 more intersections. And so hence we get a total of 7. That's why we add them up in this particular spot, because we add them up in this particular spot right here. And then for the 100 spot, we just get 2 intersections, right? We don't get anything more from anywhere else here as well. So it's saying the same exact thing. And so this is in essence what's going on in Japanese multiplication. Now, there are a couple of kind of special cases that we need to think about. For example, what if we had more than 9 intersections in one particular spot? In other words, what if we needed to carry over to the next place? Well, that really isn't all that bad. So for example, let's, instead of 13 times 21, let's do 13 times 31. You'll see why I chose this number very soon. So we have a 1 from the 13, 3 from the 3 in the 13, and then we have 3 from the 3. Oop, those are a little too close. See, if you put them too close, you're not going to be able to distinguish the lattice points. And also, let me kind of fix this one a little. And then now we have 1 more from the 31. So again, I'm going to draw it out just to help divide it up into groups right here. And then mark our intersections. So 1, 2, 3 in the hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the tens. And then 1, 2, 3 in the ones. So we know that we're going to have a 3 in the 1 spot. Now, just like how we would carry in normal multiplication, we have 10 intersection points right here in the 10 spot. So all we're going to do, just like how we would normally do, is keep the last digit, and then the first digit we would add to the number of intersections in this spot right here. So 3 plus the 1 in the 10, right? Because there was a total of 10 intersections. Kept the 0, and then I'm adding this 1 to the the 3 intersections right here for a total of 4. And that's our answer, 403. And then maybe one more example just to see how it generalizes. Let's do the case of, I don't know. Let's do 3, 2, 1 times 1, 2, 3. So I have to draw my lines kind of carefully here so it doesn't get all messed up. But so we have 3 lines from the 3 and 300. Oops, see, from the 3 and 321. Then we have 2 more. 2 more from the 2 and 121. I'm sorry. 3 lines from the 3 and 321, 2 lines from the 2 and 321, and 1 line from the 1 in the 321. Now we're crossing that basically with 1 line from the 1 in 123, then 2 lines in the 2 from 123, and then 3 lines. 3 lines. Sorry. 3 lines. Third time's a charm. No, that's not. Maybe if I go the other way. There we go. 3 lines in the 123. That last digit there. So hopefully now you can see we're actually going to be dividing it up into 3 groups, but the 3 groups are going to be a bit more complicated. So we have this first group right here. We have the second group right here. Or I'm sorry, 5 groups, not 3. We have this third group that actually is going to have 3 like places of intersection of this fourth group. And let me draw this one a tad bit better. This fifth group. So now we're basically this spot right here would be the ones place, the tens place, hundreds, thousands, and 10,000s. So now what we're going to do is again mark our intersections. So we got 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I guess I should probably be writing these down somewhere. So we had a total of 3 intersections right here, 8 here, 14 here, and then 1, 2, 3, 4, 5, 6, 7, 8, and then 3 more, right? And this makes sense to me because why the intersection numbers follow like a sort of symmetric pattern, right? 3, 8, 4, 3, 8, 14, 8, 3, because the numbers that we chose are like exact opposites of each other when it comes to how the lines are drawn. So of course we're going to get a symmetric intersection pattern because we basically multiplied symmetric numbers together. So now what we're going to do is start from the ones place. So now we have 3 here, 8. We're going to keep the 4, and we're going to, or did I count that wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14. Okay, yeah. We're going to carry the 1 here to get a 9, and then keep the 3. And that's our answer. 3, 9, 4, 8, 3. And we're done. So I hope you found this video helpful and you can see why Japanese multiplication is literally the same thing as the multiplication that you've already done, but it is a kind of a cool trick, I guess, to kind of show somebody, or also multiplying 2-digit numbers very quickly. For example, if I were doing 13 times 21, I would be a lot more sloppy with it and I'd get it done a lot faster. You might see all of this and you might just go, oh my gosh, it might just be easier to just multiply the 2 numbers together like normal. And, maybe you might be right. But in the case of 2 by 2, like 2-digit numbers by 2-digit numbers, I think it's quicker this way. If I were doing it, I'd go 1, 1, 2, 3, 2, 1. And then I'd go, all right, we got 2, we got 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3. So 273, like that. But whichever way floats your boat, I just thought it was cool to see. And with that, we're done.